Hi folks, we're going to talk about Pythagorean theorem and its converse in this video. So first thing we're going to talk about, just the Pythagorean theorem that we've known for so long. It's used to find the missing side of a right triangle. Sides A and B are called the legs. Side C is the hypotenuse. And that formula, A squared plus B squared equals C squared. Been using this for a long time, so this should be review. All right, so let's look at a few examples here. Number one, we've got the two legs, and X is in the hypotenuse space. Remember, hypotenuse is going to always be the longest side and across from the 90-degree angle. So we're going to set up 8 squared plus 13 squared is equal to X squared. 8 squared is 64. 13 squared is 169. 64 plus 169. 233, and then we take the square root of both sides to get that out of there, and we would attempt to break down that square root of 233. So X is the square root of 233, and we'll give a decimal approximation for that as well. What's in the instruction says round to the nearest tenth. So let's get the exact value and the decimal approximation. So square root of 233 here. And we're rounding to the nearest tenth. So we look at the 6, makes the 2 go up to a 3. So 15.3. And again, you need to make sure that if you're finding the hypotenuse, it is the longest side. If you work it out and it's not, you've done something incorrectly. All right. Let's look at another one here. Here it's just right triangle kind of rotated around. We still have the legs, and we're looking for the hypotenuse. So we have 22 squared plus 27 squared, and it doesn't matter which one you put in as A and B. It's equal to X squared. 22 squared, 484. 29, 27 squared. And we're going to add those together. 1213 is X squared. And then we take the square roots. Square root of 1213 and its approximation. So the square root 1213. 34.8 is what that rounds to. And then number 3 changes it up a little bit. Here we have the hypotenuse and the longest leg. We're looking for the shortest leg there. So we're just going to set up X squared plus 7 squared is equal to 9 squared. So it'd be X squared plus 49 is equal to 81. Subtract 49. X squared is equal to 32. Then when we take the square root of those, we can simplify the square root of 32. We're doing the factor tree things. 8 and 4, 4 and 2. Two pairs of 2's. So that would be X equals 4 radical 2. It's approximation. Square root of 32. 5.7. Okay. So we're going to simplify those square roots when they will. All right, another problem here. This one we've got decimals already in the problem, so we're not going to worry about simplifying the radical at the end. We're just going to go straight to a decimal answer. So we have a leg and the hypotenuse. So we're just going to set up X squared. It's 19.1 squared. It's 30.5 squared. And 19.1 squared. And don't round until the end. or 364.81, and 30.5 squared, 930.25. And we're going to subtract. And answer minus this answer, 565.44. And we would take the square root of both sides. Square root of that answer, 23.8. Look at the 7, makes the 7 go up. 23.8. All right, let's look at another strange picture here. We have a triangle, and it looks to be an isosceles triangle because it has the congruent marks on each side there. So that means that this side over here is also 24. And they drop this perpendicular down from that in between the two congruent sides. And what that does is it bisects these two pieces here. So that would mean we have a right triangle that each of those are 11 each. So we can set up a similar problem where we're finding the leg x squared plus 11 squared is equal to 24 squared. And that's going to allow us to find what's called the altitude of that triangle. So 11 squared would be 121. 24 squared is 576. When we subtract, plus 121, 455. And I know 91 is prime, so there's nothing I can do with that. Take the square root of each side and get the 455 under the radical is the exact value, the decimal approximation for that, 21.3. We have our solutions there for number 5. Number 6, that's not a triangle, is it? Well, it is a right trapezoid. And what we can do is we know that this measurement would be the same as that measurement there. So x would be here, and then we know we're taking 5 off of that, so that's going to be 13. So we're cutting that space up into where we can find a right triangle in there and work from there. So we know x squared plus 13 squared equals 16 squared. X squared plus 169 equal to 256. Subtract 87. Well, I know 87 is divisible by 3 times 29 times, and 29 is prime, so that's not going to break down any. So we take the square root of each side. X is equal to the square root of 87, and approximation for that 9.3. Okay. Now, number 7. Again, we're trying to find an altitude of this and figure out what's going on there. So what we can do with this is create two right triangles so that we can find this. There are two right triangles there, and we can call this A, and maybe call this one B. It doesn't really matter. And we're just going to find each of those separately and then put them together to get X. So B squared plus 12 squared, we'll do the one with the bigger numbers first, equals 29 squared. B squared plus 144. I don't know what 29 squared is. 41. And then subtract 144 from that. 697. And take the square root. Decimal approximation for the square root of 697. 26.4. There is one of our pieces. Let's find the other piece using this right triangle here. So we have A squared plus 12 squared equals 14 squared. A squared is equal, or plus 144 equals 14 squared, which is 196. Subtract 52, and then take the square root of each side. Small approximation for that. Square root of 52. 7.2. So that's A. And we have B, so we're going to add A plus B. It'll be 26.4 plus 7.2 is 6 and 33.6. That's what X is equal to. So we'll have to end around probably to get that one done. Let's look at another figure here. So here we have two right triangles that share a side, and we need to find the measure of this part. X is all we're looking for, but we've got a missing side on two different triangles there. So we're going to work with this triangle first because it has more information. We know a leg and the hypotenuse of that one, so that would allow us to find this leg, which would then let us set up and do the bigger right triangle there to find the X. So I'm going to call this Y and work that one out. So we're going to have Y squared plus 10 squared is equal to 25 squared. 100, and then that'd be 625. And subtract 525. And take the square roots. So 525 is divisible by 5, 1, 5, 25. So it's going to be 5 radical 21. And then I don't want to use a decimal approximation for that because I'm going to use this in my next problem. So I'm going to use that exact value to find the actual side that I want out of that. So I'm going to set up that problem with 5 radical 21 squared plus x squared is equal to 28 squared. So this is going to be 525 plus x squared and 28 squared, 784. We would do subtraction. 259. Make the square root. $16.1. Okay, let's look at number 9 there. We have a trapezoid, isosceles trapezoid. It's isosceles because these two sides are congruent, so we know that's 20 as well. And then they want us to find x, and we know that this entire base here is 40, and this base up here is 26. So that's going to cut off the same amount on each end. So that means this is 26 as well. So how much is left on each end? So 40 minus 26 would be 14. But it's 14 total, so that would mean that each of those is going to be 7 apiece.